All right, let's do some practice. This is set C in your notebook, page 28, and this is practicing dimensional analysis with units raised to a power. If you need to watch the teaching video for that, go ahead and click back in the teaching video so that you can follow our new process for using converting units raised to a power. Okay, so the first thing that we need to know is just what the exponent or powers are on these. So if we notice on this first problem that it's a millimeter squared to meter squared, that means that I'm going to have to do each of my conversions 2 times because I can see it raised to the second power. For problem number 46, I'm going to have to do each of those conversions 3 times because I see it raised to the third power. And so the process of dimensional analysis does not change. The only difference is that we're going to have to do each of our conversion factors 2 times because we have to take care of both of those dimensions. It might be length times width, or it might be length times width times height, and so we have to do those conversions that number of times. So I'm going to start with problem number 45, and problem number 45 says 1,000 millimeters squared going to meters. So if I use my conversion map to go from millimeters to meters, is just one metric conversion, but I'm going to have to do that metric conversion 2 times. So I take millimeter, put it to the bottom, I'm going to meters. I know that 1,000 millimeters is 1 meter, but because of the 2, I have to write that conversion 2 times. And so that allows my millimeters to cancel out. And so I will have 1,000 divided by 1,000 times 1,000, which is 0.001 meters squared if I put that into my calculator. Okay, top divided by bottom. All right, so let's look at problem number 46. When we look at problem number 46, the process is going to be the same. We have 23 centimeters cubed, and this time we're going to meters. But I'm going to have to do each of my steps 3 times because of that cubed. So centimeters to meters is a metric conversion. 100 centimeters is 1 meter, but I have to copy that conversion down 3 times to handle all of the dimensions of that. And so that allows my centimeters cubed to cancel out, leaving me with meters cubed. And I'm going to need to put that in my calculator. Remember that when you put the denominator in the calculator to make sure that you hit parentheses. So I'm going to, in my calculator, I'll start out with 23 times 1 times 1 times 1. That's just going to be 23. Divided by, and then I put in my parentheses, 100 times, oh, missed a 0 though, times 100. And that's going to give me 0.000023 meters cubed. Okay, moving right along, we're going to do problem number 47. Problem number 47 is 56 kilometers squared to meters squared. So I see the 2. I'm going to have to do each of my steps twice. Kilometers to meters is a metric conversion of 1 to 1,000, but I'm going to have to do that 2 times. And so I'm going to end up with a really large number in this case. My kilometers cancel, so I have 56 times 1,000 times 1,000. 3, 1, 2, 3, divided by 1 and 1. And so that just leaves me with this answer. So we can see when we're doing units raised to a power, our numbers between start and end change dramatically because we're doing those steps so many times. Okay, question 48 is 23.4 inches cubed, and we're going to centimeters. I've got that cube there, so I'm going to do every step 3 times. Inches to centimeters is just a single conversion. 1 inch is 2.54 centimeters, but I'm going to do that 3 times to account for that cubic unit. And so I would take 23.4 times 2.54 times 2.54, 2.54 times 2.54, and then on the bottom I just have 1s, and so I end up with a lot of digits. I can only keep 3 of them, so I keep 383, and that would be centimeters cubed. Okay, problem 49 takes 56.8 centimeters cubed, and it's going to go to inches cubed. So centimeters to inches, but I'm going to have to do that 3 times because of the cube. And 1 inch, 2.54 centimeters in 1 inch. That gets rid of my cubic centimeters, and so I have 56.8 divided by, and then I'm going to have to put the 2.54 times 2.54 times 2.54. And that gives me, I get to keep 3 digits, so 3.47 inches cubed. Okay, the last and the most difficult of the problems is problem number 50, just because it requires a couple different conversions. We have 10 feet squared, and we're trying to get to centimeters squared. So according to my map, I'm going to have to go feet to inches, and then inches to centimeters. Okay, so 1 foot is 12 inches, but because of the square, I'm going to write that twice. And then inches to centimeters, 1 inch is 2.54 centimeters, but I'm going to have to write that twice as well. And so when I go to do my multiplication, it's just going to be all the way across the top. So that means I'm going to get a really big number. 10 times 12 times 12 times 12. And then, oh, hold on, I lied. Let me try that over again. It's just squared. So that's 10 times 12 times 12 times 2.54 times 2.54. It's only divided by 1s on the bottom. And I get 9290.304. But I have my first value, my starting value is 10, which is only one significant digit, so I can only keep the 9. So I'm just going to get 9,000 as my answer. And that will be centimeters squared, because my inches will cancel out and my feet squared cancel out. Okay, and I got that because I had to round, only keeping 1 digit, so everything else rounded down. Okay, that is units raised to a power.